Okay, question 5. Vectors p and q are shown in the diagram below. Find the resultant vector p plus q. Express your answer in component form. Okay, so like we said before, adding vectors, we would add them head to tail. Okay, and we just add the top and the bottom numbers. Okay, now this is quite interesting that we've laid this out because this does make you think a bit about what the vector is. Okay, so if we look at vector p, okay, they're kind of making you work for this first mark by saying, well, what are the vectors? Okay, well, how far along and up is vector p? Well, we're going 1, 2, 3, 4, 5 along, and we're going 3 up. Okay, so we're going 5 along, and we're going 3 up. But don't forget, though, we've got our axes, so we've got our x and our y. X is going to be positive in this direction and negative in this direction. Y is positive in this direction and negative in this direction. Okay, so yeah, Y is positive, but your X is negative. Okay, you're going back the way. Okay, you're going. Sorry, wrong way around there. Sorry. Um, your Y up 3 is positive, but you're negative 5. Okay, because you're going back 5. Okay. Same for Q then. So we're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4. So for that one, we're going 5 and 4. But this time we're going. Sorry, actually, that's terrible. I've counted that in the wrong direction. Sorry, we're going 1, 2, 3, 4, and then 1, 2, 3, 4, 5. Sorry. Because when you look at these, what you've got is your X and your Y. Yeah? So you're going along, then up and down. So 4 and 5. Now 4 is positive, but 5 in this case is minus, isn't it? Cool, sorry about that. Just to double check. Yeah, so that one was along and up. Sorry. So when you add them together, you'd be adding them nose to tail. Before we draw them, let's just do it standard. Let's just say minus 5 and 3 and 4 and minus 5. So let's just add these together. So minus 5 plus 4 is going to give us minus 1. And 3 plus minus 5 is basically 3 take away 5, which is going to give us minus 1, minus 2. Okay, so no surprise, you get a mark for knowing what these vectors are, and a mark for actually adding them together. Okay. Now, if you were to actually draw that out and draw them head to tail, you should find that it goes left 1 and down 2. Okay, so let's try that. So if we add them head to tail, so there's P, there's the start P, and there's the end of P. So can we put Q onto here? So see, I've got Q. See, actually put that on there, right? In fact, I wonder if I can do. Let me try and insert a little line here. Let's see. This might work. Yeah. So there's my line. So there's Q. So I put Q up here. Oh, it's the technology's failed me. Look, it's not letting me do it exactly as I want. Okay, it's close enough, right? So that line, if you imagine it's from here, it's actually going to that dot there, okay? And that makes sense, doesn't it? Because we're going minus 1, minus 2, yeah? So that would be the resultant. If we added them head to tail, that would give us the resultant. So actually, in a way, this is quite nice because you could, if you want to draw it in physically and just double check your answer, yeah? I don't know how many folk are doing that, but you could P plus Q. Oh, yeah, that's good, okay. I actually think, let me see, you could have drawn it this way and still got the marks. You didn't have to do this. If you drawn this and not minus 1, minus 2, yeah, it says correct nose to tail diagram and state the components of vector P and Q. I'm not sure actually. I'm not sure if you got the marks if you didn't. If you drew it and wrote these, that's totally fine. But you didn't have to draw these to write. You could have just counted the boxes. Okay. But yeah, I don't think it would have been enough just to have drawn this line and just said the answer. I think you've always got to state what the vectors are, looking at the marking scheme. Okay. Yeah. Point is, this is interesting because it lets you see that you can check your answer, and that's a really good thing to know going through this. If you double check your answer, double check it. Okay. It was the same as up here. That's why this was dangerous as an answer because it looked like it could have been right. You know, the A was very similar to the A squared, but sometimes the A squared is a massive number and then A is much smaller. So if you see a massive number, you know, if you got 100 in there, you'd be like, no, that's not right. But square root of 100 gives you 10. You're like, oh, that makes sense because it's like an 8, 9, 10 triangle or something like that. Okay. So yeah, I think that's quite good that you could graphically show that. Okay, question 6. The Earth is approximately spherical, that's true, with a radius of 6,400 kilometers. Okay, calculate the volume of the Earth and give your answer in scientific notation correct to 2 significant figures. Okay, so we need to remember scientific notation, right? That's fine, and 2 significant figures. That's important. Okay. But the first thing we want to do is work out the volume of the Earth. That's the main question. So, if we're going to call it a sphere, what's the volume of a sphere? Well, I don't know. I always forget the volume of a sphere. Well, don't stress because there's so many volume equations up here. Okay, we've got volume of a sphere. Oops, volume of a sphere. We've got a cone and we've got a pyramid. Okay, now actually you've also got a cylinder because pi r squared h. Oops, that is the volume of a cylinder. Okay, so it's actually hidden in the volume of a cone because if you've got a cylinder like this, okay, if you were to put a cone inside it, so say you've got a cone that's meant to go to the center. If you put that inside a cylinder, this cone would be 1/3 of the volume of that cylinder. Okay, that's what this is trying to say. Okay, so you've actually got the volume of a cylinder, if you forget that, and within that, to work out the volume of a cylinder, it's the circle times the length, isn't it? So actually, in there, you've even got the area of a circle. So there's not a lot you don't have on that front page. Okay, you've actually got a cylinder as well and the area of a circle. The only thing they really don't give you is circumference is equal to pi d. It's really the only thing you don't get. Okay, so when you come to work out sectors and things like that, so you want to know the length of a sector. Not the length of a sector, an arc length, sorry. It's going to be pi d times theta over 360. Okay, that's the only equation you really don't have in here. But yeah, area of a circle, volume of a cylinder. Okay, so 4/3 pi r cubed is what we're going to use, and that's up on the front page. So brilliant. So 4/3 pi r cubed. So again, you should be thinking, this is brilliant. What a great wee paper. I've not really had to work too hard so far. Pardon me. Vector question was very straightforward, and now I've just, I'm given this equation. This is brilliant. So the mistake people make is they forget it's r cubed, first of all, and everyone forgets the difference between diameter and radius. Okay, so this is the diameter, yep, and the radius is half that. And they actually tell us the radius, which is very helpful. Okay, so 4/3 times pi times 6400 cubed. Okay, so just remember the cubed, and sometimes we'll give you the diameter, not the radius. So just remember to change it if you need to. So I'm going to do 4/3 times pi, which is just the number on my calculator, times, and I'm going to put it in brackets, 4600 cubed. Okay, where's my cubed button? Okay, so that's come out for me as 109806621944 Okay, so would that be right? Oh no, because it needs to be scientific notation and it has to be correct to 2 significant figures. Okay, so first of all, let's find our significant figures. So these 2 numbers are our first 2 numbers, so they are significant. Okay, the rest are going to go to 0. Now, find your place. This is our last significant figures. This is our place. Look next door. 5 or greater, add 1 more. We're going to have to round this up, aren't we? So this is going to round to 1, 1, and then the rest just becomes zeros. Okay? Yeah? If we put a 0.0 in there, that'd be wrong. That'd be considered significant. Okay, so don't do the 0.0. Okay? And now we need to just turn it into scientific notation. Okay, so there's our decimal point. How many times over? So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1.1 times 10 to the 12, and our units are kilometers cubed, actually, for that one. Okay. 3 marks are going to solving the equation. You get a mark for the actual answer to the power of 12, and then doing two significant figures is the way they've done it. So you're kind of getting 2 marks for these two bits. Okay. Now this bit, what did I want to talk about there? Ah, yeah. Why was it 1.1? Well, this number in the front here has to be between 1 and 10. Okay. If you find yourself with like a 10 point something, that's wrong because you can move this over. So say we had 10 point, in fact, let's say we had 11, times 10 to the 11. Well, no, let's do 1.1 times 10 to the 12. Okay, so we want a number that's bigger than 1. Um, yeah, I want a number that's bigger than 1, but it's got to be less than 10. So see here, this is bigger than 10, so it means we can adjust the notation here. But we don't want to stop. We wouldn't go any further. For example, we wouldn't put 0.11 times 10 to the 13, for example. Okay, so those two would be wrong. This would be right. So just the point here is to remember this number has to be between 1 and 10. Okay, it is okay to have something like 1.001 times 10 to the whatever. Okay, that's all right. Yeah, so you might end up with like a big decimal number in there. That's okay, but you certainly shouldn't end up with 20 times 10 to the something, and you shouldn't have 0.98 times 10 to the something. Okay, it should be bigger than 1, and it should be less than 10. Okay, dokies. So, yeah, I think that's that question covered. The approximate volume of the moon is this. Calculate how many times the Earth's volume is greater than the moon's. Okay, so we just said that the Earth is 1.1 times 10 to the 12, and we know the moon is 2.2 times 10 to the 10. So how many times the Earth's volume is greater than the moon? Well, I'd be dividing these two numbers. Okay. Okay, and that is going to come out as 50. So for that one, you're getting a mark for your working and a mark for your answer. Now, if you wanted just to check you had the correct answer, you got it around the right way, okay, you can just do the moon times 50 and see if you end up with the Earth, okay, or divide Earth by 50. So again, it's a way of checking it. Also, it's how many times the Earth's volume is greater than the moon's. So you'd be thinking, well, I'm going to have a number greater than 1 here as well. So if you got it around the wrong way, you would have ended up with, I think, 1 over 50, so 0.02. So if you got it in the wrong way, you think, well, that can't be, that's getting smaller, isn't it? If it's less than 1, the number is getting smaller. Okay, so how many times is the Earth's volume greater than the moon's? It's going to be a number bigger than 1. So actually for this, you can't really go wrong if you just think about it logically. Okay, and again, people see these numbers and it's big numbers and they get a bit upset. But if you just imagine that the Earth is, if the Earth weighs 100 kilograms and the Moon weighs 10 kilograms, you'd be quite happy to say, well, 10 of them go into 100. All right, so just sometimes think, what kind of number would you be expecting from this, and then you could check it. Moon times 50 is going to give you this. Okay, so yeah, don't have too much on that. Probably the big one is just remembering this number between 1 and 10. Take your time, read the question, make sure you get every little bit of it, because most of the marks here are actually in the last bit, the scientific notation and the two separate figures. You're only getting 1 mark for this. Still an easy mark to pick up though. So again, please don't give up. Given the volume equation, you're given a radius, come on, that's an easy mark, all right? And for this one, again, if you didn't know question 1, just pick a value for Earth, just pick a bigger number than that and do the sum. You would actually, I think, still get the marks because it'd be considered a carry mistake. Okay, so think of something. Okay, well, I'm going to just pick a number twice as big as that. That divided by that is 2. Okay, just try something to demonstrate that you can do this question as well. Don't just think I can't do it because I've not got an answer here. They want to see as much the strategy as the use of the correct numbers. Okay,